Question 4. You're told that the function f is defined by 1 minus 2 over x plus 4 plus x minus 8 over x minus 2 by x plus 4. X is an element of real numbers and it's not equal to negative 4, or this will be undefinable, and the same for this, it's not equal to plus 2. By forming a single fraction and simplifying, show that f of x is equal to x minus 3 over x minus 2. Okay, well if we take this as the denominator, we put everything over that, so x minus 2 by x plus 4. You can see here the x plus 4 is going to have to cancel with something on the top. So how would we keep the number 1? Well, x minus 2 by x plus 4 over the same thing is 1. Now we have minus 2. The x plus 4 is already there, so we just have to multiply that one by x minus 2. And we have our plus x minus 8. So multiplying this out, we're obviously going to get a quadratic that factorizes, and then the x plus 4 part must cancel. So let's multiply it out. X squared plus 4x minus 2x minus 8 minus 2x plus 4 plus x minus 8. I'll leave the denominator for a minute. So we're going to have x squared 4x minus 2x minus 2x plus x. So that's just going to give me plus x. The 4x and the minus 2x's will cancel. So plus x. And then I have minus 8 is minus 16, plus 4 is minus 12. So that's going to give me x plus 4. There's my x plus 4 by x minus 3 over x minus 2 by x plus 4. So you can cancel my plus 4's, which is equal to x minus 3 over x minus 2, which hopefully is what they were looking for up here. So that's part 1. Part B, the function g is defined by g of x is equal to e to the power of x minus 3 over e to the power of x minus 2. And x is an element of real numbers, and x is not equal to the natural log of 2, which would give this a value of 2. Differentiate g of x to show that g prime x is equal to e to the power of x over e to the power of x minus 2 to be squared. Now, you can see immediately this is the bottom, and we have the bottom squared. So that just should give you a memory of the quotient rule. So the quotient rule, you can go to the tables and get the rule, but if you just remember it like this, it's always the bottom squared. And what I would do is I differentiate the top and differentiate the bottom. So what's e to the power of x going to give you? If you differentiate it, it's just going to give you e to the power of x. And similarly with the bottom, differentiate e to the power of x minus 2. You're also going to get e to the power of x. E to the power of x differentiates to e to the power of x. So it's always the bottom by the top differentiated. So the bottom is e to the power of x minus 2. The bottom by the top differentiated minus the top by the bottom differentiated. And that's when you're looking at your dy dx in your tables, that's what it's telling you to do. But try and remember the bottom squared on the bottom by the top differentiated minus the top by the bottom differentiated. Now we multiply this out, we're going to e to the power of x by e to the power of x is e to the power of 2x with your rules of indices minus 2e to the power of x minus e to the power of 2x and plus 3e to the power of x. Now, these two cancel straight away, and we're just left with 3e to the power of x. Let's take away 2 of them, which is just one of them, over the bottom squared, which is what they were looking for in the question. Part C, you were asked to find the exact values for which g prime x, what we just got, is equal to 1. So let's let this equal 1, e to the power of x over e to the power of x minus 2 to be squared is equal to 1. So e to the power of x is equal to, if we multiply out this bracket, or if you want to write it twice, e to the power of x minus 2 by itself. So we're going to get e to the power of x is equal to e to the power of 2x minus 2e to the power of x minus 2e to the power of x plus 4. So we bring the e to the power of x across, I'm going to get e to the power of 2x minus 4 of them, and then minus another one of them, so that's minus 5 e to the power of x plus 4, and that would be equal to 0. So this is like your substitution where you let y equal, or if we let e to the power of x equal, let's say y, because we have an x in the question already. So that's going to be e to the power of x by e to the power of x, which you can see would give you a y by y, which is a y squared. And then we get minus 5y plus 4 is equal to 0. Now we can factorize this, y by y plus and a minus, so they're both minuses, and you can see it's minus 4 by minus 1. So y is equal to 4 or 1. Now that means that my e to the power of x is equal to these two values. E to the power of x is equal to 4. That would mean that e would have to be the natural log of 4. E to the power of ln 4 is equal to 4. So the natural log of 4 is equal to, if we type it into our calculator, 1.386. And e to the power of x would be equal to 1. Well, anything to the power of 0, not 0, I'm thinking ahead. E to the power of x equal to 1, so x would be 0. E to the power of 0 is equal to 1. So these are your two values.